Okay, so what we are about to go over is the test review for test 2 for 8th grade. So I'm going to go over it, and I will do my best to have a really good angle. I do not have some of the same setup as I do at school. I'm currently in my bedroom recording this, so we will do our best, and it will be fantastic. So let's get going. Okay, so the first thing we're going to see is the word acute angle. Now, if we remember, oh good lord. If we remember correctly, an acute angle is an angle that is less than, oh, the Sharpie was not a good idea, 90 degrees. If you want an example, it would look something like this. Smaller than this. This is a right angle right here. It's going to be smaller than that. So obtuse. Well, that's going to be an angle smaller. Oh, wait, no. Lied. Bigger so instead of looking like this, it's going to look something like that. Okay? Now, a right angle, already established what that is, but let's go over again. An angle that's 90 degrees. Supplementary angle. Skip this. Skip this. Just don't worry about it. I took it off the test even. So, don't worry. All right. Transformation. That is when we move a shape. There are 3 ways we can move a shape. There's, I forgot to change this here. Translation, which is when you move something up and down or side to side. Reflection, which is when you rotate it. A rotation, which is where, wait. Oh, good God. Okay, I know this stuff. Rotation is this. Reflection is something like this, okay? See, it's the same thing. I know it shows different sizes, but same thing, but just flipped. You just flipped it over. Reflection of my hand is just the same thing, but with my other hand. So I have my 2 ring boxes. The reflection of it, same thing. Now I know it's a perfect square, so let's do it like this. See? You can see that it's a reflection. All right, moving on. Prime notation is something like when we move you label the new shape. So we have A prime, B prime, C prime. Paralines. Paralines. Lines that never meet, such as an equal sign or train tracks. Intersecting lines. You can draw it like this. We can know that at 90 degrees, which the important at 90 degrees that don't intersect at 90 degrees is important because perpendicular lines do intersect at 90 degrees. Okay, so that's our vocab. So feel free to pause this and rewind it, go back. That's some of our vocab. So let me turn the page. Sorry, my bad. Oh, great, the Sharpie butt through. That's fine. Transversal lines. So it's when a parallel line cut by a line. Alternate interior angle. So that for right here would be like here and here. Alternate interior. The alternate exterior angle would be like here and here. Corresponding angles are like here and here. They're both the upper, they're both on the left side, and they're both the upper ones. The hypotenuse is the long side of a right triangle. So this side, usually right here. Usually it's the diagonal. It's almost always a diagonal. And the Pythagorean theorem is how we find that. So a squared plus b squared equals c squared. Now it says, here's the shape ABC. ABC. Apply the three types of transformations. Come on, go and focus. Thank you. Label them with the type of transformation. Remember prime notation. So it can really look like anything. So if I choose to rotate it, I have my triangle, A, B, C. All I'm asking for, have my notation, and then tell me, rotate. If you reflected, tell me reflect. If you moved it, so you moved it up, just show me. And it's translate, not transferred. I changed it for the test though. Now this says rotate the shape JKLMN negative 90 degrees. So think of it as a coordinate plane. So this was 90, 180, and then 270, 360, but we're going negative. So it's just going to come down from here to here. And now it's going to be K, L, M, J. That's what it's going to look like. Proceeding on to the next one. Ooh, without any Sharpie marks. We love that. It says transfer shape PQRS along the vector CD. My D's right here. And it should be translate. Miss Heiss made a boo-boo. But basically, as long as your shape moves up in this direction, I don't care where you put it because you're moving it up. So you can put it here. You can put it here. But it's going to be P, Q, R, S. Now, can PQRS, from this problem, go back to its original spot? Why or why not? Well, it can. It just needs to change to vector DC instead of CD because it's going the opposite direction. Now, does the size change when it's transformed? Why or why not? No. As I've told you guys many times in class, am I 5'3" when I stand in one spot? Am I 5'3" if I'm standing next to Rihanna? Am I 5'3" if I'm standing next to Jeremiah? Am I 5'3" if I'm standing by the cabinet? Yes. My height did not change. My height does not change unless suddenly my shoe breaks and I'm like now limping because my heel broke. My height stays the same. We just moved it. We only moved it. Rotate and reflect the shape. CDF. So first we're going to rotate it. So I'm going to rotate it this way. Now, if you choose to rotate it the other direction, that's fine. But this is just how I chose to rotate it. So as long as it's rotated. And then reflect. So now it's going to reflect. So it's going to look like C prime. D, actually, it'll be double prime. F double prime. And then E double prime. Got stuck to my bracelet. Transfer. Cross that out. Translate. And rotate shape GHIJ. So that just means I'm going to move it. So I'm going to move it down. Again, you can move it however you want. There's no wrong answer for this. As long as you move it, you are fine. So I moved it. So now I'm going to do my notation, my prime notation. And then I'm going to rotate it. So I'm going to turn it. And now I'm going to put, here, let's do it this way. It just has to be something like this. This is not the end all be all, but as long as you translate it, which is move it up and down, side to side, and then rotate it, which is turn it like I did, you're fine. Same thing here. I'm going to cross it out. Translate. So now, I moved this one down. And then I went to reflect it, which means it's going to look like this. Okay? Tracking? Excellent. Last page. Okay. Now this one, I admit when I was younger, I used to struggle with this, but now as an adult, I go, wow, why did it take me so long to get? Because it's actually a lot easier than it looks. So angle 1, this angle right here, 135 degrees. Angle 6 is 45 degrees. Based off that information, please use the measurements to find the measurements 2 through 8. I don't need a protractor. No protractor needed. What I can use is that I know a straight line is 180 degrees. Okay? Now, this line here, line L, we'll name him L. Cute, has a smiley face, is 180 degrees. But this segment right here, till that line so rudely cuts it off, is 135. But if I know the full thing's 180, that segment 1, is 135 degrees. So, what's the other segment? Well, I'm just going to do some quick subtraction. Borrow 10 minus 5. It's 45 degrees. Now, I can know from corresponding angles that these are going to be the same. See, straight across from each other, these can be the same. Or I can figure out the measurement for 5, which is same thing. 180 minus 45 equals 135. Oh my gosh, guys, this is crazy. And, you know, this is a straight line too, right? Oh my gosh, so what if this 45 degrees and this is 135? And look, this could be 135. And we would know this because this is an obtuse angle. Bigger than 90 degrees. 90 degrees looks like an L. This is bigger than an L. And this is like a little squishy thing. But we would know this because of our definitions for alternate interior, alternate exterior angle, and corresponding angles. But anyway, there you go. The line, 180 degrees. Even though it's diagonal, it's still 180 degrees. This, 180. The circle here, if you want to be really technical, 360. So it's just going to be, you're going to add up, and it's just going to equal 180, 180, 180, and 180. Now, for our last two problems, this is actually easier than it looks, and this is probably one of the easiest things you'll do. It says, find the length of the hypotenuse of triangle ABC. So I have, this is 3, 4, and we don't know. So we're going to use the formula a squared plus b squared equals c squared. Now, c squared is just the hypotenuse. But I'm given sides 3 and 4. 3 squared plus 4 squared equals c squared. Now, squared just means it's multiplied by itself that many times. So what's 3 times 3? 9. 4 times 4, 16. C squared. It's 9 plus 16, 25. Now I'm going to take the square root of it. Just going to be 5. Now, it says find the length of like UV on the triangle TUV. Okay? So all you're going to do is the same thing. A squared plus B squared equals C squared. I know my C squared this time. 13 squared plus, we'll make it 5 squared, A squared. Same thing. A squared plus, and you guys will have calculators for this. I have this memorized. 25. 13 squared is 169. I need to isolate my A squared. Now the inverse operation of addition and subtraction, so I'm just going to subtract from both sides. It's going to give me A squared equals 144. Square root. Plug in my calculator, or if you just know like I do, I know that this is 12. So that is your test review. If you have any questions about this, feel free to message me at any time, but I hope this is helpful and have a wonderful day.